All right, so this topic, one of my favorite. Okay, atoms and molecules. Now, I think earlier part of the year, you already have learned about formulas and so on. You learn about elements, you learn about mixtures and compounds. Actually, some schools decided to teach this topic because it goes hand in hand with the others in the beginning. So you might see, okay, certain things that we have covered before, all right? But let's hope that you will enhance your learning, okay? So don't be too worried. You already know something about it. You know what are atoms, what are molecules, isn't it? We learn about formulas. We learn about how to count the number of atoms in the molecules also. So it's a little bit of a recap, I would say, and then adding on some extra knowledge. Right. So lesson outline, you're going to describe atom as an electrically neutral entity. So atoms are always electrically neutral, and later on we will explain further why. Okay, so it has this nucleus, an atom has this nucleus right in the center, and then you have electrons moving all around it. Okay, you need to know that atoms of the same element contain the same number of protons. Okay, recognize that ion is formed when atoms gain or lose electrons. Later, I will show you how it happened. Okay, not in this slides though. All right, but as we do the questions, I'll be showing you more. You also need to show understanding that molecules of an element consist of a fixed number of the same type of atom combined together. This is not something that you don't know. You already know this. Then show understanding that molecules of a compound consists of a fixed number of different types of atoms combined together. Now, if I want to give example of the molecules of element, I can give this example. Hydrogen gas, oxygen gas. All right. So this is how they will look like if you are talking about the molecules. Okay. If I want to show the sharing of the electrons, yeah, I will need to show an overlap. Okay, but in general, it's just two atoms combined together. We call these diatomic. Diatomic molecules, why? Because they always combine in this way, H2O2, N2. Two atoms in one molecule. All right. So when I give examples of molecules of compounds, I can give example like H2O. Okay, so if I have one oxygen, then I have two hydrogen. This is just showing you how they are arranged without the sharing of the electrons shown. Okay, so this is water molecule. This is a compound. Why? Because it's made up of two types of atoms. See? Different types of atoms combined together. And we always emphasize on fixed number. That means water must be H2O. It cannot be H3O. Okay? It cannot be H4O. It cannot be HO. My face suddenly turned very fair, no? Then after that, turned very dark. These few days, it has been like that. I don't know what is happening to the camera, but don't get a scare, okay? Just focus on the slides. Now, so if you look at this again, fixed number is important, even this also, because we are talking about molecules, all right? Fixed number, like H2 must always be H2. Okay, of course, there is a substance called O3, that is ozone. Okay, that's ozone, but ozone is just O3. This is oxygen gas. You cannot have oxygen gas having the formula O3. Understand? Okay, it has always got to be O2. Right, then this is the part we already have learned. The very last point, state the number and types of atoms. If I were to give you a chemical formula of a compound, which is calcium carbonate, okay, this is also found in eggshell, chalk powder, all right, limestone. Okay, if I were to ask you how many types of atoms are there, what am I asking you? What do you think I'm asking you? If I say, how many types of atoms are there? You can type into the chat if you wish to. You can also unmute yourself to tell me. I think early part of the year, not exactly that. Okay, so if I ask you to state the number and then the type of atom, if you can't recall, don't worry. Okay, let's recap. So this particular compound is made out of calcium, right? And then carbon as well as oxygen. So how many types of the atoms? 3 types. Correct. Yes, good. Okay. And then how many atoms are there altogether? Yeah. Okay. Now you get it. Yep. Good. So if you're talking about how many atoms, then you're calculating all of them. If I ask you how many types, it's actually like how many elements there are. So when they ask you types, you will be referring to elements. So far, so good. Okay. So definition about atoms sure will be tested. Okay, and it's amazing. We have students always lose marks. You just need to define it as the smallest particle, okay, of an element that can exist. They are the building blocks of all matter. We are all made up of atoms, okay? And inside an atom is amazing. All right, it's so small, we can't even see it with our naked eye. But inside the atom, there are 3 particles, okay? 3 particles. 2 of them are found inside the nucleus. Hold on, Chin Lei's here. Right? So 2 of them are found inside the nucleus. What are they? The protons and the neutrons. Okay, protons and the neutrons. Then the electrons are found outside, surrounding the nucleus. Okay, they are very small, smaller than the nucleus, or shall I say smaller than the protons and the neutrons, even better, saying it this way. Now, there are certain things about the protons, neutrons, and electrons you need to know. Okay, one is actually their position. Where are they found? You need to know neutrons and protons are inside the nucleus. Electrons are in the electron shells. Do you see this circular lines here? Okay, these are the electron shells, we call it. So electrons are found generally here. Cannot go inside the nucleus. There's no way it can happen. All right. And then you need to know the charges as well. Okay, the charge of the protons, neutrons, electrons. Right? So we will be talking about it later. Now, do you see this statement here? Okay. Protons are positively charged. Okay, neutrons are neutral. And this tells us that the nucleus is actually positively charged. Okay, because inside the nucleus, you have the neutrons. Okay, usually we use N to represent neutrons, P to represent protons. Okay, neutrons, as the word suggests, it's neutral, no charge. Okay, protons are usually remembered this way. Okay, protons starts with P, positive starts with P, so protons are positively charged. That's how I remember when I was a child. Okay, when I was learning this. Then electrons are, okay, because protons are positive, electrons are the opposite, they are negatively charged. You see the last sentence here? Electrons are found in the orbitals. Don't worry about this term orbitals if you cannot remember. We also call them the electron shells. All right. So it's like surrounding the nucleus. They carry negative charge and they move around the nucleus only. Okay, they are extremely small and have a negligible mass. All right. So if I were to look at the next slide, Okay, so they talk about the charges. This is positive for the protons. Neutrons are neutral. Okay, and then electrons are negatively charged. Where are they found? Protons are found inside the nucleus, neutrons as well. And then the electrons are very, very small. They move very easily at high speed around the nucleus. So the charges are stated to you here. Okay, +1, 0, and then -1. So far still okay. Yeah, you will start to have questions when we start to work on the worksheets. Now, if you look at this slide now, okay, you already have the slide. Where did I obtain this thing about oxygen? Where do you think I obtained this? Can someone guess? Yes, the periodic table. Okay, so if you take a look, let me just show you very quickly the periodic table that I have. Right, this is actually the periodic table in the O-level exam paper. Okay, the actual O-level exam paper, right? This is the periodic table that's attached to the last page. Okay, so students actually look at this when they are sitting for their exam. They get all the important information there. So if we look at the periodic table of elements, there's this proton bracket atomic number. Okay, this is the key. Key tells you what are the various numbers or the letters or the name, etc. So the proton bracket atomic number is the, let's say we are talking about this particular atom here, right? Or this element here. Proton number is 4. Can you see that? Okay, you can see my mouse moving. Okay, so Be is the symbol for that element. They call it atomic symbol. It's just basically the symbol of that element, which is beryllium. Okay, the symbol is Be. And then the name is beryllium. And then relative atomic mass is 9. So what is the meaning of this? Okay, we come back to our slides. Let me explain to you. So what is the meaning of this? Okay, we have the proton number earlier, proton bracket atomic number, right? Okay, it refers to the number of protons. Relative atomic mass is actually the number of both protons and neutrons, okay? So protons and neutrons, meaning this number at the bottom, which is the relative atomic mass, is given by N and P. So it's number of neutrons plus the number of protons. Or you want P plus N also can. No problem. Yep. So this is obviously number of protons. All right. So you look at oxygen here. Okay, if I want you to let me know how many protons, how many electrons, and how many neutrons are there, will you be able to tell me? Okay, protons will be quite simple. Yeah, quite straightforward, right? It's actually 8. How about the number of electrons? Okay, 8 also. You very sure, LeBron? Why is it 8? Why the number of electrons will be 8? They are the same. So the number of proton equal to the number of, okay, not exactly neutralized, but neutralized, we use it for acid, bases, and salt, okay? We call them electrically neutral. Okay, electrically neutral, right? So the number of protons and the number of electrons will always be the same for all atoms. Clear? All atoms. So now, this will be 8 because P equals to E. Short form, I do this to tell you that number of protons equal to number of electrons. Okay, number of neutrons is actually obtained by this number minus away the number of protons. just so happen that it's all